how do you actually construct the region over which the value of the function xy is being calculated, that is being integrated. Let us do the other way around. Let us start with this figure and try to look at this integral, okay, whether it makes sense. If of course, the order of integration I desire is first with respect to y, so I incept with the lowermost boundary definition, travel vertically and hit the uppermost boundary definition. The upper limits are understood, the inner limits are understood, the geometry is understood. Now all that I got to do is just change the order of integration and then evaluate it, right? In this particular problem, the limits are changed simply by changing x to y, y to x. Now let's look at one more typical university problem where the same concept of changing the order of integration and hence changing the limits or splitting the integral we would like to look at. Now when you look at this particular example, you'll have to first make all your observations and then represent the situation graphically, then change the order of integration and therefore accordingly change the limits and finally evaluate it. So it's very, very important that first we make our observations once we look at the problem. Now the problem on hand is the integral given, where the integration is first with respect to y, then with respect to x. That is, y is the inner integral, x is the outer integral. And you can see that the limits that are defined for the inner integral are that of the y. So obviously they are in terms of x. And the power is not equal to 1. So therefore obviously it belongs to the curve. The boundary definitions are going to be characterized by curves. If it were in terms of x, it would have been straight lines. But now since it is x square and root x, obviously we are talking about curves. The outer limits are obviously the points that are got by the intersection of these curves. And that is 0 to 4e. Now, how do you actually construct the region over which the value of the function xy is being calculated, that is being integrated? So that is very, very simple. So first step is to look at the limits of the inner integral. The first one, the lower limit being y is equal to x square by 4a. That means x square is equal to 4ay. This is one parabola that is got from lower limit. Right? Clear? What about the next one? The upper limit is y is equal to 2ax. For a beginner, let me tell you, if the integration first is with respect to y, then just put y is equal to the lower inner limit and y is equal to upper inner limit. And then square it up, you get y square is equal to 4ax. This is 2. And let me say upper limit. I can also say inner lower limit, inner upper limit. Remember this very, very carefully. So these are the two limits that help you define the region over which you are computing or integrating the function xy. So now this is one parabola which is symmetric about the x-axis, and this is one parabola which is symmetric about y-axis, because y is equal to x square is an even function. Here you can see x is equal to y square. With respect to x, it is an even function. So therefore, x-axis, it's an even function. So therefore, so these are the two parabolas. And if I represent them graphically, here you go. The parabola which is symmetric about the x-axis is represented in red, and the parabola which is symmetric about y-axis is represented in blue. And the common area over which you carry out the integration of the function xy is this. So therefore, this is very, very categorically established. But now let us do the other way around. Let us start with this figure and try to look at this integral, okay, whether it makes sense. If I want to evaluate the integral of xy over this region using double integral, how would I proceed? I incept of course, the order of integration I desire is first with respect to y. So I incept with the lowermost boundary definition, travel vertically, and hit the uppermost boundary definition. Lowermost boundary definition is what? X square is equal to 4ay. So therefore, what is my y? Because if I am integrating first with respect to y, then my limits obviously are defined in terms of x. Always remember that. So y is equal to x square by 4a. So that forms my lower limit. And what about the uppermost boundary definition? Y square is equal to 4ax. So if I want y, I will have to take square root, which is 2 root ax. And what about the 0, 4a? That means this point of intersection has to be 4a, comma 4a, because you are traveling horizontally next, because the next order of integration is with respect to x. So you are traveling horizontally from 0. This is one extreme point and this is another extreme point. So it is the x coordinate of these two extreme points that go to form this limit. Clear? So now my next question is very simple. How would I compute this 4a? 0 is obvious because both these parabolas meet each other at the origin. But what about 4a? It's also quite simple. So let's consider the two parabolas. Y square is equal to 4ax, and the second equation is x square is equal to 4ay. Can I solve them simultaneously? Because I am interested in the point of intersection. So how would I do that? Substitute x or y in one of the equation. So now that I have the definition of y here, I can substitute because I need x. So what is the definition of y here? It is x square by 4a, right? Can I plug this over here? Because I have y square here. So that simply becomes x power 4, because x square by 4a I'm plugging over here. So it is getting squared further. So it becomes x power 4 by 16a square. 16a square. Why? Because I'm having y square here. Y definition from this is x square by 4a. When I plug it over here, it becomes x power 4 by 16a square, right? And that is equal to 4ax. What I can do here is I can simplify, and that becomes 64a cube x. So what I can do here is bring this to the LHS, take x outside, I get x cube minus 64a cube, that is equal to 0. Now I have got two possibilities. One is either x equal to 0, which is this possibility, or I have x cube is equal to 64a cube. Note that 64a cube is a perfect cube, because what is the cube root of 64? It is 4. 4 4s are 16, 16 4s are 64. So therefore, the two values I get, either x equal to 0, x equal to 4a. And therefore, we have cracked this perfectly. The upper limits are understood, the inner limits are understood, the geometry is understood. Now all that I got to do is just change the order of integration and then evaluate it, right? So let's try and do that. So now, how would you actually change the order of integration? It is y to x, so x to y it should be. So let me do that for you. So first it's going to be x instead of y, then it's going to be with respect to y. That means I'd be traveling horizontally first, and then I would be traveling vertically. If I travel horizontally, I'll be traveling from this parabola to this parabola. That means my boundary definition would be first this parabola, then this parabola. So my inner limits would be in terms of y, because I would be integrating with respect to x. So how would my first limit would be defined? Because I need the definition of y, so which is simply y square by 4a, because that is equal to x, because I'm talking about this parabola. And I'm ending up with this parabola. So what is the definition of x there? I will have to take square root. So that would be root 4a y. Okay, so root 4a y. So this is what exactly you see here, everything in terms of x, but structurally absolutely same, but it is simply changed to y because of the parabolic symmetry. Okay, so everything was in terms for x here, everything changed to y because symmetric about x, symmetric about y, structurally both are same. So this is what you get, and of course the function to be integrated x, y. And what about the outer limits? Now it is the extreme points of y. 0 maximum is 4, 0 maximum is 4, so this is 4a. Now what follows is basic integration for you. This is all done. Now let's try and integrate and finish this problem. So this is very clearly understood that I would be traveling horizontally from this boundary definition to this boundary definition, and then I would be considering the extreme limits of y. 0 maximum is 4, right? 4a rather. So that is what we have put here. So let's evaluate this integral and finish the problem. So therefore we have got our new integral because that is changed. So 0 to 4a does not change. Why? Because whether you are considering along x 0 4a, whether you are considering along y 0 4a, that remains the same. So therefore what about the inner one? Here it is in terms of x. If you look at the symmetry, you don't have to worry about anything. You can simply change x to y, you get your limits. And here again it is root of 4ay. It is ax. Of course 4 I have kept inside the root, here it is taken out, but only thing is x is simply being replaced by y, and that is because of the symmetry of the problem. One is symmetric about x, one is symmetric about y, and that is why you are looking at like that. So x, y, and then the first is with respect to x, then is with respect to y. It is infallible because the moment you look at the limits which are in y, you will automatically write x here, then y here, right? So now if I integrate with respect to x, what I will get? I will get y constant, I'll get x square by 2, and what are my limits? My limits are root 4ay and then y square by 4a, and then integration with respect to y 0 to 4a. So first I will put the upper limit root 4ay and then the lower limit, and then subtract it, then multiply that by y, and then carry out the integration. So what I will get now? I will get 0 to 4a, y which was kept constant, and then you had x square. Of course half I will take out, and what you had was y square by 4a, and then here it would be root 4ay. You don't even have to look at rather remember, because everything is very similar to what you have over here. So if I substitute the upper limit, what I will get? I'll get 4ay because you are squaring it up, and then here what you will get? You will get y power 4 by 16a square, and then multiplying this by y, so this becomes y power 2 plus 1, and then dy, and then what are the limits? 0 to 4a, and then this is half, right? So now if I integrate once again, what I will get here is very simple. Half, here you will get 4ay cube by 3, and then minus y power 6 by 6 into 16, 96 a square, and the limits are from 0 to 4a. How did I do? Multiply the result by y, so I got y square y power 5. When I integrate, I get 4a y cube by 3 minus y power 6 by 6. There is already a 16, 16 6 are 96, 96 a square, 0 to 4a. Very simple. Now if I take that to the next slide, then that becomes half 4a y cube by 3 minus what you have here is y power 6 by 96 a square. So y power 6 by 96 a square. So 0 and 4a. In a situation like this, you don't have to worry about the lower limit, because the moment you put the lower limit, everything simply goes to 0. So only about the upper limit. 4a, if you consider the cube, it would be what? 64a cube. You can't forget, because you took the cube root to get the value of x. And of course, the y also is 4a. So therefore, 64 into 4 is 256a power 4, right? Because a cube you get, there is 1 4, a power 4 by 3, and of course this half would be there, and minus this is also quite easy, because you can write it as 16a square into 256 a power 4. I'll tell you why exactly I did that. I'll give you the complete reasoning. Because you have y power 6, this can be split as y power 2 into y power 4, because 4 to the power 4 is nothing but 256, and 4 into 4 is 16. So that is how you will have to use to simplify things. Now you can cancel it out. 16 ones, 16 6, it's quite easy. And here also you have 256 to the power 4, 256 to the power into a power 4, which can be easily taken out, but there is a 2. Half of 256 is 128, so this becomes 128 a power 4, and inside the bracket what you have is 1 by 3 minus 1 by 6. This is quite easy, because half of 1 by 3 is being subtracted from 1 by 3. That could clearly means that you get 1 by 6. So 128 a power 4 by 6. So you can further simplify that, but you can keep it as 128 a power 4 by 6, right? Because even if you simplify, it is 3 by 18, which is 1 by 6. So this can further be simplified. So this is 64 a power 4 by 3. So this is the final answer. Very, very simple to evaluate. Now, let me walk you through what exactly that transpired. By looking at the limits of the inner integral, the area becomes very, very clearly defined. So first is y is equal to x square by 4a. That means it is x square is equal to 4ay, which is the parabola symmetric about the y-axis. And this is y is equal to 2 root ax. If you square it up, you get y square is equal to 4ax, which is again parabola symmetric about x-axis. And once you define this region, what we did, we also said that we want to find the point of intersection. How did we find? We manipulated these two parabolas. I took the definition of y and brought it over here, and I found that two possibilities of x equal to 0 and x equal to 4a. One is this and one is this. So we could get the limits also, the area also. Now we wanted to change the order of integration from y being first to x being first. So we had to travel horizontally from this boundary definition, that is this parabola, to this parabola, and accordingly my limits were redefined. The only difference that you get here is, since one is symmetric about x, one is symmetric about y, in this particular problem the limits are changed simply by changing x to y, y to x. That's what exactly you see here. There is x here, x square here, there is y square here, there is root y here, there is root x here. Everything else is absolutely same. And upper limits, of course, 0 to 4a, whether you are talking about y, x or y. Here we are talking about y. The extreme points of y are 0 and 4a. So therefore that is also done. Then what is the next step? Integration. First you integrate with respect to x, keep y as constant, you get x square by 2, substitute the upper limit minus the lower limit, and once you did that, what happened? You get this particular point and then integrate it further by multiplying whatever the result that you get by y, and then put upper and lower limit. These are basic integrations which we have been doing. And once that is done, what happens? You get 4ay cube by 3, y power 6 by 96 a square. Now here I'll tell you one simple trick that you can employ. 4a cube, you know, that is 64. 64 into 4 is 256 a power 4. But here, since it becomes complex, what you can do is you can split it as y square into y power 4. Y square will be 4a square, which is 16 square, and y power 4 is 256, just like this, a power 4. And here you have 96a square. You can always cancel 6 times, right? 6 times. And what you get, 256 a power 4, if you take it as common, there is half here. It becomes 128 a power 4. It is like subtracting 1/2 of 1 by 3 from 1 by 3, which is 1 by 6. And 128 a power 4 by 6 will give you 64 a power 4 by 3. But I'll reiterate, whenever you confront the problems like this, look at the limits of the inner integral and then sketch the area and then understand the limits for the changed order of integration. So let's move on and look at more discussions. Well, engineering and math are absolutely inseparable. We interventions day in and day out try our level best to make math as simple as possible and also of great practical value to every aspiring engineer. Do you want us to reach the masses? Please like us, share and subscribe. Do not forget to turn on the bell icon.